Good afternoon everyone, welcome to the channel. Today I want to talk about another dimensionality reduction technique which is known as t-SNE in short. The full form is T-Distributed Stochastic Neighbor Embedding. We can use this technique for performing nonlinear dimensionality reduction just like UMAP as I showed in previous video. So let's get started. I will use a different dataset compared to my previous video. In my previous video I used digits dataset. In this video I will use one dataset which is also available in sklearn. So let's import our at first give a heading. So heading align center. So T-Distributed Stochastic Neighbor Embedding. In short, it is called TSNE. Okay, so at first I have to import the required libraries for performing visualization using TSNE. So import required libraries. Okay, so as usual import pandas as pd, numpy as np, matplotlib dot as plt. So from sklearn dot preprocessing standard scalar. From sklearn import datasets dot manifold import TSNE. Okay, so that's all we need. Sorry, sklearn. Okay, let's load sklearn's wine dataset. So datasets dot load wine. Data will be wine dot data. Labels will be wine dot target. Let's create a data frame. Pd dot data frame. This will be data. We want to add the labels as well. This will be labels. Let's see the first few samples. So there are 13 features starting from 0 to 12, and we also added the classes as well. Let's quickly check the shape. 178 samples and 13 are features, and last column is the classes. So trying to separate features and labels. Okay, this is 4, I think. Separate features and labels. So for separating the features from our data frame, we have to drop the last column. And our classes will be the last column only. So all rows and last column. Let's check the shape quickly of our features. So we have dropped the classes from our features. It's now 13. Now it's time to perform pre-processing. So scalar, create an instance, scaled features, fit transform features. Okay, so now I think we can perform at first 2D visualization using TSNE. So let's perform that 2D TSNE. 6. So create an instance, TSNE, in components 2 for 2D, random state reduced TSNE 2D dot fit transform. Okay, we have reduced. We can now confirm the shape. So from 13 features, we have reduced it to 2 for 2D visualization. Let's see them as well. All 178 samples have appeared. Let's see only few. So we can see each has now 2 features instead of 13. We have performed nonlinear dimensional reduction using t-SNE. We can also check the unique classes. So we have 3 classes, 0, 1, 2, 3 types of wine. So now let's separate the components, reduce 2D. So component 1 and component 2. This will be 2 and this will be 1. We have to prepare a color tick. Let's use RGB for 3 classes, RGB. And we have to mention a label dict as well. So there are 3 classes. One is class 0, class 2, marker dict. Let's use 3 different type of markers. P, finally alpha dict, size of markers, one, okay. Now time to visualize after reduction. So fixed size will be 10.6, axis will be fig.add subplot. Set face color light gray. So for I in p dot unique classes. Extrude scatter comp 2D j color dict marker okay. Set X level component 1. Let's make the font size 15. I have to do the same for Y level as well. So this will be Y level component 2. Add the title as well. So title will be 2D visualization 2D visualization using TSNE. We want to make the title a little bit bigger, and finally we want to add a legend. So title will be wines, or let's say wine types. Box to anchor. Title font size will also be 20. Let's see if it works. Yes. So 2D visualization using TSNE. This is class 0 wine, class 1 wine, class 2 wine. So we have plotted this after reducing the features from 13 to 2 using TSNE. We can do the same for 3D, I think. 3D TSNE. So I have to copy few things to save some time. So now it will be 3D, and for 3D the number of components will be 3. Okay, let's confirm the shape. So previously we had 2 on, where is 178 2. Now we have 3 for 3D. Let's check the first few. So you can see 3 components. Let's copy few lines. Control C, Control V. So this will be 3D, 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 3D. We have to add another component. This will be 2. This will be 3. Now let's copy the big part of the code. So we have to change few things here. Let's make it 88. Mention the projection 3D. Projection 3D. Change it to white. This will be 3D. This will be 3D. Comp 3D 3. J. Let's bring it here. We need a Z level as well. So Z level, this will be 3. This will be 3. We have to change some things here as well on 0.43, 0.66. Let's see if it works. Yes. So this is 3D visualization. So component 1, component 2, component 3, there are 3 point types as well, class 0, class 1, class 2, 0, 1, 2. And here we have shown 2D. In this case, it's kind of understandable compared to UMap, but in my opinion, 2D is better for getting the whole idea than 3D. And this B-box to anchor, this actually takes this legend out of the main figure and puts it in another place. You can change these parameters to see the left right movement of this legend. Okay, so this is the second second example of non-linear dimensionality reduction using t-SNE. In previous video we used UMap. Okay, that's the end of this video. Thanks for watching.